Our next keynote speaker is Mr. Sonam Wangchuk, an engineer, an innovator, an education reformist. Mr. Sonam Wangchuk is working in the field of education for more than 27 years. He founded the SECMON, which is the Students' Educational and Cultural Movement of Ladakh, which aims to bring reforms in government school system in Ladakh. In 1994, he was instrumental in the launch of Operation New Hope, a triangular collaboration of the government and the village communities in bringing reforms in the government school system. The program involved formation of village education committees to take ownership and training of teachers in child-friendly ways and rewriting and publishing textbooks for Ladakh. As a result, the pass percentage at the 10th grade increased from 5% to 55% in just 7 years. Mr. Wangchuk has designed and built the solar heated buildings that are low cost, made of earth or mud. In order to solve the water crisis facing mountain regions due to climate change and fast melting glaciers, he invented the ice stupas, or the artificial glaciers, which stores the waste stream waters during the winter season in the form of giant ice cones called stupas. And this stupa releases the water in late spring as they melt. So this is when just the farmers need the water. Mr. Wangchuk is one of the 2 Indians to have won the prestigious Ramon Magsaysay Award in 2018. Ladies and gentlemen, Mr. Sonam Wangchuk is here to speak a few words about innovation in real life. Let us all give a big round of applause and welcome Mr. Sonam Wangchuk.
Thank you very much and a very good morning. I bring you greetings from the mountains of Ladakh, and thank you very much for making me feel at home, even with the air conditioning here. I feel in Ladakh. I came dressed for Chennai, and I see that some of you have had to dress for Ladakh with your clothes. That's an irony of modernization, I suppose. What we can do, we overdo. In Europe, in winters when I go, they put the heating so hot that I have to come in t-shirts. Yeah? So, talking of sustainability, I think it's an important issue to think about, and I'm so happy that while we are celebrating manufacturing here, you sir touched importantly the issue of sustainability, because all this will go as long as we can maintain that balance of the sustainability. I will share a bit of my life with you, and the common thing in both is innovation that solves problems, whether through manufacturing or without, but it's about solving problems in the most efficient ways, using least resources and creating maximum impact. So I'll share with you with some images our side of the innovation story amidst adversities, amidst challenges, sometimes innovation in thin air without maybe materials and resources also, which I'll be more clear with the help of some images that perhaps will speak more than my 1,000 words, as they say. So this is Ladakh, where I come from, top north of our country, flanked by Pakistan and Tibet, China on the other side. A very different landscape from the rest of the country or even the world. As you can see, it's more like a Marsscape or moonscape than a landscape, and when people approach it by air, it looks almost uninhabitable. And as you can see, temperatures range from plus 35 to minus 35. But if you look closely, then you see what human beings can do, even in this lunar landscape. Our ancestors, for thousands of years, have applied their mind and lived and more than survived amidst these harsh conditions. Innovation has been a part of their life. Innovation is the reason why they could survive in these mountains and do more than that. They started with carving rocks which analyzed glacial meltwaters to any sandy patches, and came armed with an innovative crop at the time, which was barley, which had the shortest season or maturing time, and that is what allowed human beings to occupy the heights of Himalayas because of this very short maturing crop. And then they started growing in these heights. Now, you would think it is difficult to farm in these places, and perhaps it is easy with your tractors and combine harvesters in the rest of the easier parts. Our ancestors didn't have those machines, but what they invented was a culture of music and dance. So every act of farming becomes a dance or a music. There's a whistle or a song that accompanies every act, and life becomes fun, even if it is harsh. And I can tell you, some of the people in huge machines can often feel very lonely, which you don't, even in the harshest mountains. So we are a minority up there, not only linguistic and ethnic, but even climatic and environmental, technological minority, because with these conditions, much of what works anywhere else doesn't even work there. So as you can see, running a tap can be a circus. And because they are just transplanted from a place like New Delhi to a place like Ladakh, and they of course don't work. Not that the technology is not there, it is not adapted, it is just cut and paste. And half the time they don't work in New Delhi also, so you can't blame. So, as I said, people not only survive, but a colorful civilization thrives here with music, dance, spirituality, languages, and so on. As you can see there, the act of winnowing with just simple implements, but accompanied by whistles and songs, can make it very colorful again in different ways. Similarly, about the cold winters, our ancestors were very innovative. They did not have the resources to switch on huge heaters and burners and so on. They would do what they could in their houses, taking heat from the animals who would be put in the ground floor and humans on the top floor, accessing the heat that goes upwards from the floor. But more important than that, and it is an interesting innovation that I observed as I grew up, our winters are very harsh, and you would think people would run away, but they are filled with festivities and colorful events. And our ancestors were very clever in putting all the festivities into the winter months. So people spend away, wait away their winter from one festival to the other. Young people are particularly eagerly waiting for the next festival in the monastery or in a village. And then summer comes, and it's a crime to have a festival or even storytelling. We say, as the greens grow, you stop storytelling or the spirits will be angry. I later understood why they devised such innovation, which doesn't involve any rocket science or machines, but it's an interesting innovation. As the greens grow, you spend your time working and not in storytelling, and it's actually preserve your stories when the greens are gone and it is dull and cold, and you spend your winter waiting for your grandma's stories and festivals in the monastery. So innovation can be made in thin air, but brings value enough to make a harsh winter very colorful and warm in many different ways. I grew up observing these innovations of our ancestors, which sometimes are not very visible, yet they do their job. But being a tiny minority in the mountains is a challenge also, especially now when it is all connected. So this is what means for young people of today when we got connected to the rest of the world from our hermitage in the mountains. In the 80s and 90s, I came across the situation in our education system. Up there, with a life that is so different from the rest of the world, suddenly the world comes and brings its education system, the schooling system and so on, and administered in a language that the children don't understand at all, and with books that are about things that they have never seen. The results were as bad as these. 95% used to fail every year. And I was shocked to learn that 95% failed, and yet the system and the people, everyone was blaming the children. You don't blame the products being from manufacturing yourselves. When 95% of the products fail, you have to look into the system. But sadly, that was not what was happening here. They were blaming the children. Sometimes teachers who would be brought almost punishment posted to the Siberia of India from Kashmir or Jammu would even say, these kids can never do well in math science. They don't have enough oxygen in the air. Pseudo-scientific devices they would make to explain why they were not able to do something with the children. And of course, the last thing you can do with children is to break their confidence. Of course, they can't manufacture oxygen, right? So they might as well give up the little efforts they might be doing. So it went from bad to worse and worse. I came across this situation while I was doing my engineering, and for some reason I had to earn my own expenses to do my engineering. And I decided to teach these 10th grade students in Ladakh during the vacations, the winter vacations, so that I could support my own education. I did more than that. I did support my education, but more than that, it changed my life. This experience, teaching the students, opened my world to what was going on in the education system. I saw that there was nothing wrong at all with the children. They were very bright. They could grasp every concept, however complicated, in science, in math, when taught in the ways they learn. But the system was completely against them. I just was mentioning that it was a language that they didn't understand. Children in Ladakh who speak a Tibeto-Burman language, which starts from right to left, start their schooling in Urdu and Indo-Persian, which starts from right to left. And all the science, maths are administered in this language for 7 years, and then suddenly in the 8th year, it all switches to English. No 3 languages in the world can be as different as these. And of course the kids get confused with no use made of the language that they come equipped with from their home, Ladakh or mother tongue. Then secondly, the context was completely irrelevant to their lives. In a place like Ladakh, with minus 30 outdoors, you go A for apple, B for ball, fine. A is an abstract squiggle, so apple makes it a little more concrete for a child to associate. Ball does. But you copy paste everything and it becomes F for fan, minus 20, and you wonder what this contraption is. Yeah? And the teacher explains, this makes people cooler. And children wonder why would they want to be cooler than minus 20, So this is just an example how irrelevant sometimes it becomes when you just copy paste mindlessly especially for little children. And no wonder the results were like this. And that, as I said, changed my life. I started working on how to change this system. Engineering was my first love. I had chosen it because I liked the chapter on optics in my 11th class. Lenses and mirrors, concave and convex, fascinated me, and that's why I chose mechanical engineering. But then I realized that in life it's not just about what I need, but often about what needs me. And these kids, I thought, needed me more. So I decided, rather than heading to that long queue of engineers waiting for jobs, I would do something about this system and liberate thousands of aspiring bright minds. Thank you. So now I'll share with you how this story of the School of Innovation unfolded from this experience of a winter while I was in college. So soon after my engineering, I finished and went into bringing changes in the schools of Ladakh. Initially, we were naive. We started together with some like-minded friends to teach and coach these 10th grade students who would otherwise fail. And it worked. More and more would pass. But then we thought, if we keep repairing these broken products, we'll be doing so for 5 decades, and the system will keep producing broken products for us to repair and do the charity. So we said, no, we should stop it and go to the source where it all starts, so that products or children don't break in the first place, and we don't have to do this charity of helping them. They should not even know that we did it if we do it in the system itself. So we took one school as a prototype. Any change, it's always good to do a prototype and show the change. In any case, it is difficult to go to the government because we wanted to change things in the government schools, which is where it all begins. Every village there is a government school and no other school. And that's where we wanted to work. And to go to the government and say your system doesn't work, we'll change. They'll say get lost, right? Especially if you're only 21 or so. So what we wanted to do was change one school and then get people involved wanting that change. And in a democracy, if people want, then government can't say no. They can say no to me, or they can say yes also if they are particularly friendly or happen to be a relative, a commissioner or a minister. But such changes last as long as the minister lasts. The next one reverts it back. But if the people change their priorities, then no government can take it lightly. The next one will also have to respect that. So we wanted a people-based change of priorities in the people's programming of their minds. So we changed one school where we organized the village people to take ownership of the school in the form of village education committees, and then we redid the textbooks from what I explained, F for fan, to what they can relate to in the mountains, what can come useful in their lives and what will excite the children, and then trained all the teachers to do the things in an engaging way, experiential way, rather than just memorizing, chanting science. And to cut this story short, this started having an effect, and slowly this 5% success or 95 failure started changing to 7, to 23, 36, and finally nowadays around 75. And I always say this proved an important scientific theory or revelation for the world, that it was not oxygen in the air that the kids could not perform. Now for those who still failed, it was 25%, but that's smaller than 95, but it's a huge number nonetheless. Even 1%, I say, is a huge number if it touches you or your children. right? Otherwise it's a figure in the statistics. But if it is you, then 1% is all it takes. So therefore we said no child should come out with this experience of being a failure. And those who fail in a system that doesn't work actually means something positive. If in a bad system, good ones may not succeed. In any case, these schools are classrooms where children bubbling with energy are trapped for 8 hours, lectured and made to write, scribble in paper. That's not how human beings learn, or that's not how they have learned for millions of years. Throughout evolution, we have learned in direct nature, doing things, facing challenges as hunter-gatherers. We were always, our children were with grown-ups, taking on wild, risky situations and learning. As farmers settled later, also they were learning outdoors and engaging, and to do that, nature gifted them through evolution with huge amount of energy to do physical, actual things outdoors. And suddenly, we trap them in classrooms in the last 300 years, this factory schooling model, and then blame the children if they feel restless and can't do it. Because the energy gifted by nature has to come out, and it comes out in some ugly ways, and we call that teenager rage, rebellion, rather than addressing the root of it. And therefore we thought those who didn't do well in this system, if they didn't learn the way they were taught, we can teach them the way they learn. So with a batch of so-called failures, we went onto a desert in the middle of nowhere and wanted to create a school where these young people can engage their energies also, not just intellectual, input. So this was to build a school that's designed by the students, built by the students, and run by the students. Now, over the next 5 years or so, we created this school campus that was an alternative school and a different one. To begin with, here the admission criteria was not grades and percentage. It was that you have to have failed in the system. Yeah? If you have done well, then you may be on the waiting list in that system. So here they would learn in ways they would learn. And it was also an experiment for grown-ups to see how we can learn to live in harmony with nature, be comfortable, but not destroy the earth for that, meaning sustainable partnership or symbiotic relationship. So therefore, this school was built all using natural materials like mud or earth, which comes right under our feet. Anybody, rich or poor, can access it. And powered by the sun, which shines right over our head, again, free for all, rich or poor. All it takes is human resource, our 2 hands and imagination, to make the two meet, and anyone can have a dignified, happy life. And this school was not only designed and built with the students, but also is run by the students, where the students form a little government and run it like a little country. They form a 2 months government. At the beginning, they have an election, and as when a group comes to power, they plan and set their goals to run this little country and execute throughout the 2 months, and then report in the little parliament they have, and thereby learn the skills of life, not from pages of a book, but actually by practicing in their own lab country. And this prepares them for life, and this engages their energies that they have gifted by nature through evolution. Rather than opposing it, we make it flow and make them into partners to run the system rather than problems to be fixed. And the little government takes on responsibilities, and the responsibilities are not mock responsibilities, they are serious, real responsibilities. So some of them might take the animals, to milk the cows and deal with everything that they need to. Others may take care of the solar gadgets that cook food or power the campus, yet others may be growing organic vegetables for the kitchen. Now, all these are engaging activities which they like to do, young people, teenagers, and yet they can be related to what they have to learn in the classroom. For example, the ones producing vegetables would sell it to the campus kitchen at a selling price, and they would work out what it cost them, and then learn practically that profit is equal to selling price minus cost price, rather than chanting this line, feeling it through their fingers in their being. And the ones that are doing milk will track the productivity of the cows on a graph and make various pie charts and graphs and relate how statistics works in life to what they actually do on this little country. While others run the power plant, which by mid-90s this campus went all off-grid, zero energy, producing all the energy that it needs, a time when these terms were not even coined. They installed the system and maintained the system. More complex scientific concepts like germ theory would be applied to preserving fruits by making jam, so that something like apricots, which all fall in August and have a shelf life of a week, goes waste, can be preserved for 1 to 2 years using their lesson in germ theory in their classroom. And then they make hundreds of bottles of jam, half of which they sell and half of which they consume. The ones that they sell finances their excursion out down the Himalayas to Kashmir or Himachal, learning geography on the way. And when they come back, they write in the campus newspaper or the campus radio, like life is, and be ready for life. This often becomes a part of life, this experience of applying knowledge to real life at the school. Some of them later have taken up the fruit preservation to a more serious level of manufacturing jam or fruit pulp that are supplied to industries in the mainland country. Others, like this woman who was taking care of guests and visitors to the campus, started her own all-women's travel company, which employs women guides, women cooks, women porters for women clients, and has become quite a known thing in the world. Others go back to their regions to add value to products like yak, milk, cheese, and so on for high-end hotels and so on. So these applications then later seamlessly become a part of their life for their livelihoods or their startups, as we may call now. Other innovations revolve around the mountain context of earth, sun, ice, and fire. Earth, as I said, is what the campus is built with. It is also an ancient technology that our forefathers mastered. And there was no reason to throw it away in the name of modernization. So we decided to build the whole campus using mud, earth, even though people would laugh at us saying, "You're taking backward steps. This is the time for concrete. You have to be modern." So we didn't see any reason. Concrete doesn't work everywhere and is a very brown material with lots of embedded energy. Whereas earth, right under our feet, is perfect for a cold region and even for a hot region for moderating the temperature, humidity, and so on. So why throw away the baby with the bath water? We rather decided to add value to it by combining modern science, passive solar heating principles to the earth that our ancestors gave us, and created solar heated buildings where you can see with a greenhouse, a plastic affordable greenhouse that comes down in winter and goes away in summer. You get to see, the children get to see their chapter on heat come alive. In this chapter you are normally made to, I would say, memorize conduction, convection, radiation, without knowing much what it does. But here they can see convection is what heats my building in winter, keeps it in plus 15 when it is minus 15. So the hot air that is generated by the sun in the greenhouse makes the air light, lets it go into the building through the windows, gives the heat off to the walls, becomes colder, denser, is pushed into the greenhouse to start it again, and all day there is a convection current with no fans, no machines, no power bills, just natural cycle, in a way innovation out of thin air, literally, that keeps the heat transferred from the sun to the inside of the building, and in the evening, students responsible for that close the windows and trap the heat inside. Now convection brings the heat, so does conduction through the south walls, and then the internal walls start radiating the heat to the occupants. All these principles come alive and become unforgettable. Rather than blaming children for forgetting their lessons, perhaps we need to make the lessons unforgettable. Now we started taking this further. The ancestral knowledge of earth buildings is very interesting. Concrete has a life of 60 to 100 years, but some of these buildings have been there for 1,000 years. This fort of Tingmosgan for 600 years, it has stood in the elements, rain, sun, and still stands. There must be something right. So we started reverse engineering what went right in those that lasted, and then applying to new ones. Like this fort in Saskor, 800 years old, 4 stories tall. People have plundered, taken away the roof and everything. Still it stands, exposed to the elements of nature. We started reverse engineering and applying it to new buildings. So some of our students started a startup called Third Pole Constructions. So they started building with this rammed earth technology, new buildings clubbed with passive solar principles. And they can be very traditional at the same time cutting edge modern or postmodern. Going with traditional materials need not mean being primitive. You can have a warm temperature with no fires burned, no smoke released. Buildings like those in the background are part of the campus, and life is connected, modern yet very traditional here. And now we are taking it further to take this ancestral knowledge to modern manufacturing or fabrication, to develop prefabricated passive solar houses for, say, people, of course, and the Indian Army, which uses huge amounts of kerosene to heat the soldiers in winter, which drains our economy because we have to buy Arab oil and transport it to the heights of Himalayas and then burn fires that belch smoke, polluting the environment, and often causes many deaths of soldiers because of fire accidents. So most of our soldiers these days die of fire from their heating than fire from the enemy. And it could rid them of all these and the drain of the exchequer if you use your own sun, using your own earth. What we are doing is modular Lego type blocks made of a material created by mixing straw with clay. Straw and clay sounds very old-fashioned, but if I say fiber reinforced products, like FRP or carbon fiber, it might sound more modern. So I say fiber reinforced clay blocks, but it is basically clay using the same principle as FRP or carbon fiber, using straw to strengthen it, reinforce it, and you get a product that's very light, movable, and it can be insulating at the same time, and therefore good for prefabrication. It, together with passive solar science, it will not need any heating. These buildings will not need any heating even in minus 15 to 20, thereby cutting pollution in Ladakh from kerosene. and cutting pollution elsewhere also, because we are planning on taking the straw from Punjab, where 17 million tons are burnt every year. If this goes well, it will cut pollution in Punjab, it will cut pollution in Ladakh, and result in a cleaner, happier life for people. Sun is what powers almost everything at this campus, from cooking with solar cookers, to greenhouses that produce fresh greens in winters, to natural lighting, electricity, water heating, water pumping. Even the cows at this school live in solar heated cow sheds. We learned that when we did extend this solar principle to the animals also, out of compassion, but we were surprised pleasantly when they started reciprocating generously, when our cows here started giving 2 or 3 times more milk than normal cows. It turned out it related to another chapter in the high school science, that of animals being warm-blooded and cold-blooded. Warm-blooded animals like us and the cows need to maintain their body temperatures at, say, plus 27. Even if it is -5 around, a little above that or below that can kill us, fever, hypothermia, and so on. So the poor cows have to maintain 37 in -5 cow sheds. And where do they get the energy? Food that they eat goes into maintaining their temperature. How can you expect milk? So when you do that with cheaper options like solar heated shed, hardly any cost, their food, their precious food becomes milk, and they give 2 to 3 times more milk. This could be a solution again out of thin air to increase the productivity. As I said, people laughed at us when we went for earth as a material, but we saw no reason. If they laughed, why should we stop? So we understand what it is as a material. Over the 2 decades, the world started catching up, particularly with climate change and environmental issues, and they started appreciating why Earth. By 2016, we were given at the World Earth Congress the Terra Award for World's Best Earth Buildings, thereby making us feel that we need to stand our ground when we understand what we are doing. Similarly, our solar principles of harvesting energy got us the Sustainable Architecture Award in Paris. Again, people didn't understand when we started in the 90s, but slowly the world started catching up. Now, ice. Ice can be a very fascinating world, a serious business for mountains reeling under climate change, but ice can be a fun thing for young people, especially. Ladakh, as I said, is a very cold place, and you would think people would want to run away from Ladakh. But believe me, every winter, many young people who study in Mumbai, Chennai, you will find in flights going back to Ladakh to play ice hockey. So I'll take the lighter side of ice first. And what interests young people is this sport. This is ice hockey, and it's almost like the national sport of Ladakh. Every winter, everywhere, you will see people playing tournaments and so on. A highly celebrated winter sport. But 15 years ago, we saw that it's such a good thing that we have something that makes harsh winters colorful. Great. But we saw something missing. We saw girls missing from the whole colorful world. There were no girls whatsoever playing this sport. And we wondered why. Then we thought that perhaps the reason could be that all these rinks, as they are called, where they play, are makeshift rinks on reservoirs of water, ponds, and those are not conveniently located in the town. And girls find it more difficult to commute from these in the evening, morning, and perhaps that's why they don't play. So we said, let's use some high school science and solve this and see if it is this reason. So at our school, we made some contraptions using lime as a reflector of sun and some shading, and then created a new technique of make it anywhere ice hockey rinks on any flat grounds. And we built one right outside the girls' hostel at our campus. This could perhaps be the country's largest open-air ice hockey rink. And the girls started playing. Sure enough, slowly between schools there were tournaments, inter-district there were tournaments, and we could squeeze in a girls' cup in the winter, and they started playing, and slowly they started playing bigger and bigger, and for the last 3 years they have been representing India as India's women's national ice hockey team in Asia Challenge Cup and Taipei, in Malaysia, and so on. Now, interestingly, India's national team happens to be 100% from Ladakh, because not many places play in India, and half the members happen to be from this school, where they come as failures and then excel in some field or other. Now, ice, for more serious business. So climate change is affecting most of the mountains. Two things are happening. Glaciers are melting away, and sometimes they are melting away to make lakes, and which flood the whole region. But as the glaciers shrink, farmers have more and more problems in a place like Ladakh, where it was always a desert, so water was always scarce. But now, in springtime, there is a crisis, because A, it's not warm enough in spring for the glaciers to melt, which is what people depend on. And secondly, they are smaller. So in spring, the streams are smallest and the need is highest, because spring is when every tree, plant needs water, wakes up asking for water. And yet there is only a trickle in the stream. So there are conflicts around water. But then comes summer and there is actually floods and excess of water, because the glaciers start melting. Add to that a little rain and there are floods. And this big flow continues into autumn and even winter. It lasts. And in winter nobody farms, so it just goes waste all the time into the Arabian Sea via Pakistan. So 3 years ago, together with my students, we set upon an experiment to see if winter water can be kept till early summer or spring and use it to grow things, when water is scarce. Again, people laugh. How can you keep winter water? Everybody knows by March all the ice on ground is gone. How will you keep it till May or June? We did not accept it right away, but didn't know whether we could or not. Kept on discussing whether we could keep ice from winter to summer. There were experiments on this earlier in our region, but they were mostly about making ice in very high altitudes. Now we wanted to do it at village altitudes where people can maintain it. Then suddenly one day I observed outside our school, under a bridge, a big chunk of ice in mid-May. Now that was a big clue, that in mid-May you can have ice under a bridge. But then, under a bridge is also springtime, warm, nothing different. Only thing different under a bridge is there is no direct sunlight. So we understood that it's the direct sunlight which melts the ice, and why people think ice cannot be kept, not spring ambient temperature. So cutting the sun is the key, and therefore we started working on how to cut the sun on ice, or big chunks of ice, where you can't have a bridge, or any covering material will not be economic. So how do you do that? And again, what came to our help was high school science, or in this case geometry. In geometry, we are made to memorize certain shapes have low volume or minimum volume for maximum, minimum surface area for maximum volume. You would remember perhaps spheres, extend that, and hemispheres, and cones are such shapes. Now if we make our eyes in one of these shapes, then it may last long, because these shapes have low surface area. Why? Surface area? Because the sun cares about surface area, that's where it acts. And people, they don't care about surface area, they care about volume, which is what should be maximum. So therefore we decided we should make eyes in a cone shape. But easier said than done. Cones and such huge scale would be like pyramids, and pyramids, you can ask the Egyptians, are not easy to make, right? So how do you make huge ice pyramids? Again, we started with some high school science, just by putting a pipe upstream. In the mountain, you always have an upstream and a downstream. We uses the basic principle which says water always maintains its level. If you have a pipe at a higher inlet, then in the pipe, the water will want to go to the same level, and there will be pressure to do so. And therefore, as the water comes out to go to the same level, you put a fountain, and the fountain makes it spray into the air, -20 air in winter, and thereby makes it lose its heat, or latent heat, as we all study in high school science. And then when a liquid loses its latent heat, it becomes solid. So you use liquid properties for it to go to the height we want on its own without having to lug it, and then it becomes solid, which is what you want once it drops, and it naturally builds a pyramid or cone of ice. Can we go back? And this is what we got. This was 7 stories tall, contained 1 million liters of water with the fountain, as you can see. And this was the pilot stupa that we built, and we were betting on how long it could go. Some of us said March and mid-April, maybe end of April. Finally it went till July 6th, with the ice melting slowly and giving its water over the time when water was most critical. And to build the first pilot, we needed to have some money to build, to dig up the land, to install pipes and so on. And in Ladakh, to build these monuments called stupas, people used to do collections from the whole community. And in this modern time, we thought crowdfunding is like that kind of collection. So we went on Indiegogo and collected some $125,000 to build the first stupa. So it was a challenge in itself to do crowdfunding from a place like Ladakh, where most of the time there is no connectivity even to talk with internet, almost dysfunctional in those days. We conducted that and built the first pilots. And making a working model pilot is one thing in innovation. The other half, which is even more important, is social acceptance of the new idea. Now for that, we wanted to position it as something that people can relate to. And we could have called it an ice pyramid, ice cone, but that wouldn't have meant much to common people. So we saw that in the environment you have other cones of materials other than ice, which are revered, which are respected, and they are called stupas. So we positioned it, branded it as ice stupas, and we even put prayer flags as stupas would have, mainly to position it like that, but a little bit of partial windbreak and partial sunshade on the stupas to make it last longer. So we weren't blind when we would tell the villagers that if you put prayer flags, it will last longer. It was mainly to position it that way. And slowly the ice stupas today have become almost a site of pilgrimage for people who come and bow before the ice stupa, or a tourism site at least. So for promoting solutions, you have to relate it to things that people relate to, and collaborate with various actors, like you said. To take on a challenge like climate change, we have to collaborate even with unlikely partners, and therefore to take it far and wide, we collaborated with spiritual leaders, with students and everyone, positioning it as ice stupas, as I said. These are from other years. These ones were 9 stories tall and held roughly 3 million liters of water. And the one last winter was 30 million liters of water, not one, several of them. So each year we have been trying to tenfold it. This is what the ice stupas look like. They are conical and they have an inlet, as you can see, a gate, and there are people to give you a perspective of the proportion. And yeah, this is how they are made in winter. On the right side shows how it is made, and on the left how it melts. When it melts, you collect it in a tank, the melting water in May, June, the critical months, and then through drip irrigation, you take it to the roots of all the trees. And then 5,000 trees, which were planted in a desert that has never seen any greenery, are flourishing because of this thing in springtime. So the role of the ice stupa is only to see through May and June. By July, you get natural glacial melt. So the same pipes bring that water. So it's just to fill that bottleneck, and that is what is stopping such huge deserts as that from being green. Not water per se, just that little 2 months of spring, and that's what it fills. Now, to make it sustainable, we are working on something interesting. The ice stupas have an access tunnel and a dome inside, and we are working to make those interesting and into a tourism experience as an ice hotel or as an ice bar, where people, especially from the hot climates, can come and experience, stay in an ice shelter with ice cups, ice plates, ice furniture, and so on. And that will finance water for the farmer outside, with tourists having an experience inside. We are working on some other interesting ways of solving the water issue. As I said, innovation can sometimes be with hardly any resources, just out of thin air. This is one example of recharging Himalayan springs. Throughout the Himalayas, with climate change and many other issues that it brings, springs are drying up. In Sikkim, in Himachal, in Uttaranchal, everywhere that's a phenomenon. Now, as you can see, the rain that falls on the mountains needs to recharge these springs. With erratic rainfalls, the rains just wash down and often become a flood and just leave without the springs being recharged. And one solution that has been found and is being worked upon in Sikkim, Uttaranchal, and many places is these recharging pits. You see that? So you make pits so that the rainwater doesn't just wash away, it goes into these and then stays there, slowly seeping into the hills, and it slowly then comes in the form of a spring. Great solution, but is rather expensive because so many people have to work on digging these pits to recharging pits. And they don't have to be shaped, squares and rectangles. It can be any ditches in any organic shape. So I was in Sikkim and Bhutan, and the day I was visiting or understanding these, in the evening I was in a homestay. In the morning the lady came lamenting that all her potatoes are gone. And I said, how? What happened? The wild boars, these are wild pigs, they have a habit of digging up everything in the ground, and potatoes are a favorite. So they dug up all the potatoes and ate them, and the lady was very, very sad. That gave me an idea. So if the pigs are so interested in digging up, why don't we employ them and use task force to make the recharging pits in the mountains? Wild boars are everywhere. So we are hoping to start a little study. It's very expensive to dig a whole pit with human labor. But what you could do is use human labor to drill a hole and plant. Position a favorite food for some of them, our friends, and leave a trace, a string attached or something, which then they'll start digging all night. And with the same workforce, you can put these little baits in 10 times more of area, and we'll have lots of them working for us, and not exploitation, because they get their wages right after their work. If we are able to do this, we'll be able to do it so extensively, because we have a huge workforce, by the way, so that there can be actual impact around the area. And now we are also working on applying the ice scuba technique for the disasters that I mentioned, glacial lake disasters. I won't go into detail this time. We are simulating the conditions in high valleys in Ladakh of these lakes, you can see on the right side, that happen because of the fast melting glaciers filling up any depressions, and then with rains or any other conditions like earthquakes or snow avalanche, they break and they can cause disaster like the Kedarnath one. We are working on siphoning out the lake to lower the level so that the disaster, if any, can be much smaller. That's what the government wants. And in Sikkim, we are right now, as we speak, piloting this concept of siphoning out the lake water and refreezing them into ice cubas, matrices of ice cubas, which then become a sheet of ice, meters, tens of meters thick, which keeps growing every winter, melts a little but freezes more every winter. In other words, reglaciating the Himalayas, at least attempting to, something that has not happened since the last ice age 10,000 years ago. But this is just an attempt we are doing. While finding such solutions, we started thinking that these should not be, finding solutions for your challenges should not be a one-off thing in a corner in Ladakh or a person in some place. It should become a part of every young person's life through higher education. Higher education should not be just sitting in classrooms, reading and listening to lectures. It should become applied energy to solve problems. So we now, I'll just share with you our latest thing and then finish with a short video. We are now working on applying these techniques that I mentioned to create an alternative university, which is like a makers doers university, where young people in their 20s can do much more than just sitting and listening to lectures and solve their own regional problems. In our case, mountain context. They should have a context. In this case, maybe oceans context in say Chennai. So we are working on a huge desert to make it green like what you see, and start an alternative university, which then takes young people of all the mountains of the region. It will be an international mountain university, and engages them actually on ground, apply learnings to solve problems in the area. So here's this will be financed or seeded by the Rolex Award that we got for this ice scuba project, like the others in this field 2 years ago. And using the money that we got from this award, we are seeding it so that others in the world can join us. And then once this succeeds, we hope that ripple effects will be felt in universities around the world, and things will change for young people everywhere. So again, we started a crowdfunding to start a people's university. Can we have a video there?
I've never let my schooling interfere with my education, so said Mark Twain. How about you? Do you miss your school or college days? You perhaps do. But perhaps not for the classrooms and teaching. You actually perhaps wished every day that the school be closed the next day so you could stay home. But here's a school in Ladakh where the most dreaded punishment is to be sent home for 2 weeks, where students learn by doing things, where they engage in various innovations to solve real-life problems like climate change, where they run the school themselves like a little country with an elected government and learn management and governance that way, where they learn communication by running the campus newspaper and radio, science by designing and building their own school, solar-heated mud buildings that stay at plus 15 even when minus 15 winters. Kindness and compassion through introspection and meditation. A school where the criteria of admission is not your percentage, but that the conventional system has failed you. Hi, I'm Sonam Wangchuk from Ladakh, a remote mountain region in the Indian Himalayas. 25 years ago, when I was finishing my own engineering education, I saw that schools were a pain for everyone. But for mountain children, it was doubly painful and irrelevant. Children who spoke Ladakhi or Tibetan at home were made to sit all day memorizing in alien languages like Urdu or English. F for fan, S for ship, T for train. Till recently, every year, 95% of the students used to fail in the all-important 10th grade exams. Together with like-minded friends, we launched SECMOL, the Students' Educational and Cultural Movement of Ladakh, and said enough is enough. Working with the government, we rewrote many textbooks, retrained the teachers, and organized the villagers. And the results started changing too. For those who still failed, we started the alternative school that you just saw. And the results? Tewang Rigzin went on to become a top journalist and later became the Education Minister of Ladakh Hill Council at 27. He had failed his 10th grade 5 times. Stanzin became a filmmaker and has been winning awards across countries. He had failed 4 times. Miss Tinless is today a celebrated social entrepreneur. She had failed 3 times. But now we see that the state of higher education is no better. Not only for Ladakhis, who of course are doubly disadvantaged again, but for you in the big cities too. It's time we change this. We in Ladakh are dreaming again. This time our dream is to create an alternative university that will use all our learnings from the past 25 years. Once again, a hands-on doers university, where the School of Business runs real-life companies on campus. The School of Tourism runs high-end hotels and simple homestays. The School of Education runs innovative schools. The revenues from these sustain the university while the students get free higher education and of course hands-on experience. But this is more than a dream now. His Holiness Chetsang Rinpoche, one of the top spiritual leaders in Tibetan Buddhism after His Holiness the Dalai Lama, is supporting this cause as the chief patron. The Hill Council government of Ladakh has earmarked roughly 200 acres of land, and the ice stupa artificial glaciers have already started greening this desert. A fully solar-heated, mud-built university township is being planned by some of India's top architects. Together, let's start the next learning revolution, where education is not limited to just the 3 R's, all too much to do with the head alone, where skills of the hands and kindness of the heart are given equal importance. Sure, it would take significant financial resources to materialize this ambitious dream. Recently, I was awarded the prestigious Rolex Award for Enterprise for the ice stupa artificial glaciers.
Sonam Wangchuk.
I contribute
my Rolex award as a seed for this cause. Thank you very much.
I have decided to contribute the roughly 1 crore rupees as a seed fund to finally raise 150 crore rupees for the first phase of the project. And I very much hope that you all will join me and match this contribution according to your capacities. Together, we can change the face of higher education forever, not just for Ladakh, but for the whole world. So join us. The future has already begun.
Thank you very much. This is our story, and with this university we hope to innovate further to make lives more interesting for the people in the mountains. And together with me here we have the CEO of this university project. He's a successful serial entrepreneur from Chennai who left everything here to join us there. I'm sure in the future we can definitely meet her or me. Thank you very much. This is not the end. Thank you.
Now we'll be doing the felicitation of Mr. Sonam Wangchuk. To do the felicitation, I would like to invite Mr. Kamal Bali, MD Volvo India, Mr. Shailesh Sheth, Director BFW, Mr. Ravi Raghavan, Managing Director BFW, and Mr. Praful Shinde, CSMO BFW. The felicitation will be done in traditional Karnataka style with the silk shawl with handicraft, sandalwood garland, and the national bird peacock.